In this video, we're going to look at circles. It's basically the equation of circles and how then we can work with those circle equations to solve problems. First thing to look at is what is the mathematical definition of a circle? It is a locus of points equidistant from a center. So really all a circle is a center point and some radius. A circle actually has nothing to do with the line around it. The circle is simply defined by its center and its radius, and it's every point that is r units away from the center. This right here is the completed square form of a circle, where A and B are the center of the circle, just like H and K are the vertex of a quadratic. You know, the parts inside the parentheses and out. So inside is x, outside is our y coordinate. Same is true of a circle. The number with x is the x coordinate of the vertex. The number with y is the y coordinate of, I said vertex before, is the y coordinate of the center of the circle. And then the constant that's on the outside is the square of the radius. If you were to multiply out those squared, you'd get the general form for a circle. There's like this, which is very similar to standard form of a quadratic. And the centers and the radius are still there. They're just hidden. So you've got negative g and negative f are the center, and then there's a fancy square root equation for the radius. So there are a couple different things. You can either memorize these two and be able to find the center and radius from there. Not recommended, but is possible. The other thing to do is just rely on completing the square. We've learned how to complete the square already, and you can do the same thing with a circle equation, which we're going to look at. You just do it twice, once for x, once for y. But before we get to completing the square of a circle, look at some facts about a circle, and these come into play in Cambridge problems because these are the key terms that they're expecting you to know to be able to make that jump from the text of a problem to actually solving. Okay, so the angle in a semicircle theorem states that an angle inscribed in a semicircle is always a right angle. So if you get a problem that says A and B lie on the diameter of a circle or something along those lines, or they give you a picture where that's true, you can safely make the assumption that that is a right angle. Okay, that's the angle in a semicircle theorem. You have the perpendicular bisector of a chord. Okay, so recall a chord is a line that a chord is a line that crosses a circle. So any line that crosses a circle is a chord. If a line is perpendicular to a chord and it bisects the chord, is by definition perpendicular to that line, and it means it passes through the radius. Back up. So if we have a chord in a circle, and we have the perpendicular bisector of that chord, that perpendicular bisector passes through the center of the circle. So you're going to see problems in Cambridge where they're going to say find the perpendicular bisector of line AB in one part, and then in another part of the problem they're going to say find the center of the circle. Well, you've already done part of that work because you know this line contains the center of a circle. So tangent to a circle. So if a tangent is over here, So tangent touches only once. So we've seen this already coming when we were looking at quadratics, and it would say a line is tangent to a curve, so it's touching only once. The nice thing about a tangent is that the perpendicular to a tangent is the diameter. So if we draw another one, if we have a tangent over here, the perpendicular line automatically goes through the center of the circle and is a diameter. So let's look at how we can use our information to solve a given problem. So we have an equation, and we're looking for the point A. 6, -6 lies on the circle, and find the equation of the tangent to the circle at that point. So the first things first is we've got to prove that that point is on the circle. So we have xy, we have an equation with xy. We just have to plug everything in. So we say 6 - 3 squared plus -6 plus 2 squared equals 25. So this becomes 9, 16. We get 25 equals 25. So A is on the circle. So in order to find the equation of a tangent to the circle at point A, so if we think of a circle, and we've got over here, that's A. We know the center of the circle. We need to find that. So we need to do is, our process is going to be find the slope of CA and find the perpendicular, and then write the equation. So to find the slope of CA, well, A is 6, -6. C is 3, -2. So change in y, change in x. So m of CA is going to be -2 minus -6 over 3 minus 6. So it's going to end up being 4 over -3. So my m of CA is -4/3. So my m of, I'm just going to call it A, is 3 over 4, the perpendicular. And now I have my equation. So this is where knowing point slope and slope intercept comes into play, because I can say y minus 6 is equal to 4/3 x plus 6. That is the equation of the line tangent to the circle at point A. Let's try another one. So we're finding the points of intersection of the line y equals x minus 3 and the circle. So I have x minus 3 squared. Remember, points of intersection is where they cross, so it means their values are the same. We're going to substitute them. So instead of y, I'm going to have x minus 3 plus 2 squared equals 20. So this is going to be x squared minus 6x plus 9. Then this x minus 1. So it's going to be plus x squared minus 2x plus 1 equals 20. 2x squared minus 8x plus 10 equals 20. I can divide everything by 2 to simplify, so I get x squared minus 4x plus 5 equals 10. X squared minus 4x minus 5 equals 0. It's a quadratic. I can plug it into my calculator. I can factor. I can do any number of things. So I find that x minus 5, x plus 1 is what that equation factors into. So my x is equal to 5 and negative 1. So those are my x's. So I have 5. I plug 5 in. 5, 2. And then I also have negative 1, negative 4. So those are my 2 points of intersection. If I really wasn't confident, I could plug 5 and 2 and negative 1 and 4 into the circle equation to prove that they lie on the circle. So in Unit 3, we've looked at, need to make sure you understand midpoint, gradient, or remember that is slope, length, so using the distance formula, understanding parallel, perpendicular, and how to prove if they're parallel or perpendicular. The circle facts are going to be helpful. So you've got your angle in a semicircle. The perpendicular bisector of a chord. And the tangent. So those are your 3 circle facts that you need to know. Along with slope-intercept form, point-slope form, your circle equations in the 2 form, and complete the square form, and in general form. Again, your homework for this is 2, 5, 9, and 12 on page 92.